Well, I got something put together. I wanted to test if I could make something similar to the Balatro card feel. This is the game that I've been working on a little bit. Just wanted to program blackjack. Let me get these chips out the way. They're fairly standard tweened cards. You can see it plays great. Stand. It does what it needs to do, right? 8, 9, stand against a 7, yeah. So I haven't added the card system here yet. If I click done, or exit really, go over here, momentum test. It skews the card in the direction of travel. And you can see it bounces it. Here, if I can, let me change something in it real quick. If I go to VS Code and set my conf 1920, 1080, make it full screen and borderless. Go ahead and run it. You can see the skew effect more dramatically. You can see how it kind of tilts. Yeah, there you go. You can see the tilting direction. And I think that matches pretty closely. What it kind of does, there's a couple ways I can do this. So there's this way, of course. Get out of that. I can also implement it such that, you can see here, corner towards mouse, edge towards mouse, means I need to do negative, positive. If I go ahead and run it again. And I'm going to turn off flipping as well, so you can just see the card movement by itself. Over in, where is it? Here it is. Go ahead and not tween. There. Give it a second to show up. Here we go. You can see it, yeah. And it also does it such that the width and height will change as well to accommodate the skewing. And you can see how the edge, it turns the edge, the left or right edge, towards whatever direction it's going. Which does look really neat. And it has a little bit of a bounce. Yeah. It's not implemented with any difficulty, really. All you need is this little function here. If you run the math, these are just really basic kinematic equations. It gets the, well, actually, it gets momentum, but it doesn't really use it, so I can actually take that out. Calculates new velocity given an amount of damping, just to make sure that it doesn't oscillate forever. I can actually raise the damping to like 0.95 and you can see what happens. It basically applies a force and acceleration like a spring. So you have negative k times your delta x, and there's your y, and then your cx and cy are current x and current y, applying the same force. Given the new vx, it just runs through the basic kinematic equations. Now, I could have done a more accurate physics simulation, but I didn't feel like I needed to. And just so you can see the exaggeration here, I'm going to change the fire to 3. So you can see the really exaggerated animations. See? There it goes. That's why the damping is required. Actually, let me see. If I go and turn the damping to 1, what it'll end up doing is not causing it to slow down at all. Well, I guess it does cause it to slow down. There is loss of energy with the particular set of kinematic equations that I'm using. That's what the less accurate physics simulation gets you. But you can see it's much, much more exaggerated. In fact, if it's 5% energy loss, if I go to damping and change it to 1.05, that should about accommodate. Let's see. That's closer to critical damping. You can see how it, yeah. So filling in that 5% energy loss, you can see how it just doesn't stop. But I think it looks pretty neat. There is kind of a trail. I don't know how to fix that. I don't know if that's just a trick of the eye or if it's something going on in the game engine. But anyway, let me go change those back. So damping of 0.85, fire of 2. And I can also change it back around one more time and switch it back here. Change it back to how it was because I like the effect. If I go ahead and start it, you can see it's fairly exaggerated. You can see my mouse. This is the desire here. You can see that it squishes vertically whenever it moves up and down, squishes horizontally from side to side, and you can see the skew like that. So the card kind of faces the mouse. Just, it's a very, very weak illusion, but I think it looks really neat. The way it works is by multiplying two sigmoid functions, which just produces an S shape curve. In fact, if I go to Desmos, I can show you the particular function that I do use, or something close to it. Desmos. If I am correct, it is 1 divided by, or it's 2 divided by 1 plus 2 to the power of negative x minus 1. There you go. That's it. Change this. You can see it offsets it. Want 1. Puts it at 0. And so you can see that this function approaches 1 on the y-axis and negative 1 on the y-axis, and it can be elongated by dividing x. So if I divide it by 2, it gets twice as long. Divide it by 4, it gets 4 times as long. And so it's a much gentler S-curve. And essentially what I'm doing is multiplying two S-curves together. Let me pause this real quick and see if I can get it working in Desmos. Well, I couldn't get it to work, but I can show you where the math is done. Ultimately, we have a Vx sigmoid and a Vy sigmoid. Now you can see the modifier for x is by 1,000, and that's for a good reason, because the velocity x and velocity y is determined in pixels. So for example, the sigmoid would be close to 1 if the velocity is close to 1,000. It would rapidly approach it. And so you can see this is just the sigmoid function here. And then down here, for the skew, or for the shear, really, it's negative Vx sigmoid times Vy sigmoid, and negative Vx sigmoid times Y sigmoid. With the shear, it creates a horizontal parallelogram where the top and bottom of the rectangle stay flat, but the sides bend. And a Y shear is another, it's just the opposite. The two sides stay the same, but the top and bottom end up bending. And so if I were to remove one of these, you would see that it only goes in a particular way. But combined like this, I can cause both shears to go at the same time. And so these combinations of positive and negative will determine if the card seems to pinch or angle instead of turn, and in what direction. And so that's why here, give it a second, when I move, it seems like the card faces towards the mouse. It's almost it is basically a three-dimensional, it's almost like an orthographic projection. It doesn't have true perspective or even weak perspective, so it really is just basically a parallelogram. Or at this point, yeah, it is just a parallelogram. But in the context of the motion, your brain thinks that the card is facing towards the mouse, like that. And I think it's a pretty neat effect. Yeah, you can see how it thins down dramatically. But I'm I'm gonna continue working on this and see where it gets me, because I think that this is pretty neat. Oh, here we are.